All right, so we'll today revise the concept of transport layer, and we'll go very quickly because in normal practice, understanding of TCP and UDP will require at least 3 hours. So the intent is just to revise the concepts. Okay, just a minute. Wow, this is not working. Give me a minute. Wow, it's working as a, just a minute. How is it? Well, sometimes it doesn't work. Give me a minute. What's happening? My hand is working as a mouse or pen, and this is also working as a pen. So there is some problem. Let me just. Okay, now it's working. Sorry about it. Okay. Sometimes it's difficult to understand how things really starts malfunctioning. Okay, so this is a lovely book. I mean, I would recommend all of you who want to understand networking to please go through this book. And I mean, this really very well written book. The top down computer networking, a top down approach. And very good thing is that Professor Kuros has come out with this. Kuros Rose, they have come out with video lectures. Okay, and these lectures have recently been introduced. Okay, so I would request, I mean, especially the students of MTech who have not done the course of networking, please go through these video presentations. This is really wonderful, very well, presented the basic concepts of computer networking. Okay, all right. So I have, when I was looking for contents, especially TCP, so I came across this. And always use the latest version of the book. When I went to the website, I found this. Wow, I said, wow, this is really good. Okay, so they will not get into bits and bytes. We'll try to focus on the concepts. All right. So far, what you studied, you know that network consists of these are all autonomous systems, right? Okay, now, and these are interconnected. Okay, this reason we say internet is network of networks, or it interconnects networks, right? So internet in general has something that interconnects all this. What is it that interconnects? What we can say, what is, of course there is we can say this IP layer, right? IP protocol, which especially gives addressing, IP address, right? And of course we have routing protocol. You would have studied some routing protocol, right? Especially BGP and so on, right? Okay, that those protocols give distributed understanding among, one basically so-called interface router or gateway router for each segment or each uh, autonomous system, understanding how to route the packet, and this understanding is very similar with each, right? So each so as a result of that, a packet that enters anywhere passes through various networks on the way and finally reaches at the end. And these autonomous systems are in general provided by ISPs. Okay, this concept we know, right? So we need IP address, we know routing protocols. Okay, and other important things are of course DNS, domain name server, which we have already studied. Okay, and this concept, all of you know that we have application data. It can come from email or your voice streaming and so on. And then this application data comes here and TCP header is added. Now, if this application data is very big, it's segmented or is a partition, because the size that can be carried over IP, and then size that can be carried over Ethernet or underneath link layer is kind of that limits the size of data that can be put into transport layer. Okay, so usually link layer protocols have limit on okay, just muting all of you. All right, so there is a limit, right? And that limit is of course becomes a limit of IP layer, and then becomes limit of transport layer. Of course, IP packet size is also limited. Okay, data size, right? It cannot be beyond certain number. So that also puts some limitation. All right. So the data that's coming from top from app has to go over various transport layer packets, TCP or UDP. All right. And when it reaches back, it means that now we have multiple packets that will traverse our network, like the one here, second, third, and so on. And when they all reach at the end, they are reassembled and original data is given back to application. Okay, so all this we have seen, right? So we will not get into details. So it gives connectionless, unreliable, best effort protocol. Okay, so why do we need transport layer? So what does internet do? It from a machine like your laptop to a server, it delivers the packet. IP packet that comes from your machine, it goes to other machine, a server. Why do you need transport layer at all? Anyone? See, IP packet that's entering into a machine here, and there is then large now it passes to multiple machines or routers, and finally it comes to another laptop or another server. And this is IP A, address A, this is the machine B, so we can say IP address B, IP address A and B. So IP from this machine, which is A machine, it reaches to the B machine, this packet, right? Why do you need any other layer on top of this? Anybody?
For reliability.
Very good. So this packet may be lost in between. So somebody has to take, because network layer, IP layer doesn't care about reliability. Very good. What else? Just think.
The packet should be in order.
That's fine. That's part of reliability. It will reassemble it. Very good. That is, we can say that whatever packets are sent, some numbering has to be there, so it reaches to other end. Good. But that may not always be necessary, right? UDP, does UDP require numbering?
No, sir.
So it may not be requirement, right? In TCP, of course, yes. When we need reliability, that like file transfer, every bit has to reach to other end. Okay. Now think of, I mean, just visualize. IP address is your home address, where you live. I mean, you may be living in, say, for example, in Delhi, in Hotchkiss, in certain, street. Okay. Okay, and then that there is house number said 5, house number 5, street A, Hotchkiss. That's it in Delhi. This is address. Okay, and similarly, your address is your hostel in IIT Goa and room number, or your hostel in IIT Goa and then whatever, right? Honda and so on. So now you send a letter or a box, a gift box, okay, with the home address. And now there are multiple people in your home. Okay, your father, mother, your brother, sister, and so on. Is for whom? When you give IP address or your home address, then the recipient is not known. Similarly, on a machine, we know that machine itself cannot do anything, right? You may give machine an address, but within a machine, like in OS course we have studied, there are hundreds of processes running at a time. And who is communicating? It's not the machine that is communicating. And machine is nothing without is it having OS and multiple processes running into it. So actually the processes that are running. Now these processes, so when you're delivering packet on the other end, it is delivered to to particular process. Similarly, when your courier or gift packet goes to your home, then you write the name of the person whom it should go to. Okay, and that person will pick it up. So there must be a way to IP address gives machine address. Beyond that, we need something to identify with processes. So there are multi-process, they need to send a packet. So there must be some identification process, which of course is process ID, but from not network context, we say it's a port number. Okay, all right. So we'll come to this concept. Okay, this we know. So there are two things that are needed: reliability and ports. Okay, by now you understand what port is. Okay, like your port defines within home. You can say 1 2 3 4. 1 is your father, 2 is your mother, 3 is your sister, 4 is your brother. You can define these numbers. Similarly, various application create socket, and then socket is associated with a port number. Okay, so when we send a message, a packet, when packet is received, the port number is seen and delivered to a specific socket. And socket is associated with the process, or process receives it. That's a very simple example, right? Okay. And we know TCP provides reliability and ports, while UDP only provides ports. It doesn't provide reliability because many applications don't need reliability. Okay, all right. So you're talking only two protocols, TCP, UDP. Of course, there are other protocols also. So internet is in general unreliable. So if you want reliability, then we'll have to run TCP. Okay, all right. Now the very important concept, multiplexing, demultiplexing, we have studied by now, like your letter box going to your home, right? Okay, so it will be delivered to a right person. Okay, so same thing is shown here. Okay, all right. So IP protocol is node to node delivery from one node to another node with some IP address A to IP address B. That's it. But within that, if there are multiple multiple processes, then there is a need to deliver it to them, right? So there are multiple applications that run within destination node. Okay, so that's the reason we have to do demultiplexing. Means that from this we have to send it to whoever the recipient is, or multiplexing is the reverse process. If there each one of them has something to send, then they can send it over network layer. Okay, so it's like this. Okay, demultiplexing, there these are various applications, right? So if the packet is for a specific application, it has to be delivered to that application only. Okay, and when these applications have data to be sent, these are to be sent over a network connection. Okay, so now the recipient who will receive it, on the other hand, will know based on the port number who has sent it. So right, so both TCP UDP have ports. So when we create a packet, we put port number as well, right? Source port number and destination port number. Like, if there are you and your room partner are there in the same room, and you keep your address as or you or your, let's assume your twin brother, okay, and both live in the same room, and if you say your room, if you sender's address is room address, then that's not appropriate, right? Because there are two people who live there. So you will say that write your name, that you are sending it, right? Not your twin brother. So the recipient, your father, will know that it's come from you. Okay. So that's the reason both source port number and destination port number are required. Okay. The same thing is depicted here. This application P3 is and then P4, and P3 is communicating with P1, and P4 is communicating with P2. Okay. So now the process is that it will, if it's sending over, it has to send over TCP or UDP, then it will create a socket, and socket will have a port number. So it will, when it's sending, creating packet, it will give the source port number, and also give recipient port number corresponding to socket of application P1. This socket is already formed. Okay. So destination port number, and so on, right? Okay. So now we can see that we need to, every datagram, every packet or datagram. Okay, we need whether it's TCP or UDP, we need source port number and destination port number, and in addition to IP address, IP source address and destination port address. Now this, source address, IP address, destination port address, source port number, destination, these four, combination of these four gives, uniquely defines a port. Okay. Now TCP ports are of course different from UDP ports. You would have studied this. So when you create a socket, you define a local port number. Now the port number space is also limited. So sometimes there is a problem, right? If there is no free available ports, but so those problems are there, which of course there are ways to resolve it. Okay. So we need to, when we are sending a packet to somebody, we need to define destination address and also destination port number. Okay. So now we are talking about connectionless demultiplex in case of UDP. Okay. So when receiving host receives UDP segment, it checks the destination port number in the segment. Okay. And it directs UDP segment. Segment is nothing but the part of the packet, the useful part. Okay. Into socket with that port number. Okay. So we have created sockets, for every, so these are the sockets. So when we when we want to somebody, a process wants to somebody, and then first thing it does is so creates a socket, and if then socket is associated with the port. Okay. And then similarly destination destination process will also have a socket and a port. So we just need to, sending process just needs to specify destination IP address and destination port number. All right. Okay. All right. Now in UDP, multiple processes can send to same destination port number. Okay. In TCP, it's not. So it's like this, that okay, here is a process P3 is communicating with the process P1. Okay, so there is a socket here. Like HTTP have socket number 80, right? For example. Now here it could be different. Okay, here the socket is 6428, which is known to this process. Now this process creates a socket when it wants to communicate. So this socket is created, its number is 9157. So it will send a UDP packet with source port is its own port number, this one, and destination port number is this one, 6428, associated with this port. Okay. All right. When it sends it back, same thing happens, right? It will use its own port number 6428 and destination port number 9157, this one. Now when we communicate here, so now it's a number, source port number will be 6428 and destination port number will be 5775. And when this responds back, then source number would be 5775 and destination port will be 6428. Now this all that it says that in UDP, a port, a server port can receive messages from many. Okay, all right. That's it, right? Okay, while in TCP is connection oriented, we create a connection. Even when you're communicating with server, we are creating a connection. Okay, it means that there is, when we say there is a connection, it means that there is a state information that's used on both ends. Okay, so for if your machine, when it's communicating with server, there is a unique socket that's there, right? The relationship is unique. Okay, so it's that relationship or connection is defined by four important numbers: source IP, destination source port number, destination IP, and destination port number. Okay, so receiver uses all these four values to direct segment to appropriate socket. All right, all right. So it's something like this, that okay, so here is yeah, just a minute. This is 9157. I was looking at what is port number, and this is port number 80, which is HTTP. Okay, and this will have port number 5775. Okay, so now when this is communicating in this direction, it means that from application P1 to HTTP server, okay, then it will use a socket, and the socket number will be 9157. So it will put the source IP socket is 9157 and A is a machine IP address. Okay, so now this packet will contain source port number is 9157, but destination port number is B80. Okay, and because there is a unique combination of source port number, source IP address, destination port number, destination, so separate socket is created. While in UDP there is just one socket. Okay, and similarly now this machine C is communicating with machine B, that's HTTP server here. Then it will when it's sending, it will use source port is 5775 and destination port is 80. Now there is a separate socket is required, right? Because now this will correspond to this particular connection. Similarly, the one here will correspond to this particular connection. So both end needs to maintain the state information. Okay, any question on this one? Please understand the concept of port. Okay, all right. So this, all right, this is all, and then we can see here in this chart various ports that are defined, right? These are very well defined ports, and the one which are not defined numbers can be used by any application. All right, so this we have covered. UDP will not go into details. It's no frill, barebone internet transport protocol. It doesn't care whether packet is lost or not, because a lot of applications don't care about it. Now, delivered out of order, there's a possibility that packets may be delivered out of order, but UDP protocol doesn't care about it, because many applications again doesn't care about it. And as networking in general is improving, when fiber optical cables are coming, switches are becoming optical switches, very fast switches, then most of the time packets do arrive in order. Okay, so you may not want to do extra overheads, and you may want to increase the speed of data transmission, then use UDP. Okay, so okay, all right. So these are the advantages. Okay, so I am not going to look, please go through this PPT. Okay, again, as we discussed earlier, we need source port number and destination port number. There is a length field, checksum field, and this IP data, this IP packet, the data that comes from application. And all this will go into IP packet. This will become a data part and there will be header. Okay, all right. So we will not go into details. The next 20 minutes we'll try to cover TCP, because the assignment that you will do, that's given to you yesterday, you would have received it based on TCP protocol. In general, at the connection establishment, you use SYN packets, right? Okay. So why do we need TCP? First is, of course, application may generate any size of data that we have seen in the beginning of this lecture, right? And then where IP can carry a fixed size data, right? So we need to break this, the message or the data that's coming from application into small packets. Okay, so and as one of you mentioned that packets may arrive out of order, we need to put a sequence to them. Okay, packets may be dropped, so we need reliability, right? How do we need? It means that there must be concept of retransmission of data, right? Okay, so how will you know something is missing? Until there is a, so one way to know is that acknowledgement should come from other end, that yes, I have received it. Okay, so these are the problems, right? These are the problem is solves. First is big size data put into smaller sizes, then packet can arrive out of order, put them in sequence back. Because in a file, when you're transferring file from one and text file, for example, from one end to another, you cannot afford to have data out of order. While in video streaming, it's possible that application may accept it. Okay, all right. So, and then in UDP, we know that it's just packet that's being transmitted, right? We don't have a stream concept. A stream is nothing but a stream of data. It's just bytes after bytes after bytes that are coming, right? Okay, so we don't assume a limit on that, right? So it's a whatever stream is coming on top from app, like video stream. Okay, now we have to convert this into segments, and then those TCP segments are transmitted over IP. Okay, so it provides streaming abstraction, it provides ordering, it provides reliability. Of course, this we have already seen, right? It provides ports, it provides congestion control, like we have concept of window, sliding window protocol, etc., right? So we have socket, a process sends streaming data like all these bits, and then a socket is created, and over socket, and socket is associated to the port. Okay, and then of course the port, there is a concept of buffer. Okay, and then these segments are sent to the way the socket is implemented. This, of course, there has to be buffer, and then output is taken from the here and puts into TCP. And what we show is a segment, nothing but the data, part of the data that goes into TCP packet. Simple. This we know by now, point to point, reliable in order, byte stream, and full duplex of data, right? And apart from that, that's really important is a cumulative X are sent. Okay, we'll see that later. Pipelining is concept of pipelining is there, right? You're not just sending a byte or few bytes and then waiting for acknowledgement. You can continuously send, source can send stream of data, okay, multiple segments, okay, and then wait for acknowledgement, right? So basically, look at this way, that when you're sending data from one end to another end, delay could be few milliseconds, say 50 milliseconds. And if you're just sending say 1K of data, okay, it will take certain time, sometime 50 milliseconds. Okay, and in between, this guy has to wait then until acknowledgement comes, and this is not the right way, because pipeline is empty. So you can fill the pipeline, right? You can increase the number of packets that are being sent one after other. So a stream of data is sent, and because of pipelining, bandwidth is more, and then overall, speed of transmission is higher, right? So it's of course connection oriented, which requires connection between two ends, and then is a flow controlled. Okay, such that flow control is very often we use in real life, right? I mean, okay, can you visualize some example of flow control in real life? Very often we use flow control. You think about it, right? Even your home, there are examples. Okay, this is a TCP segment structure, right? I mean, largely what we are talking here is a packet, TCP packet format. Okay, now what TCP packet format consists of: source port number, destination port number. These are very important. Similarly, now here you note that there is no IP address, right? Why in TCP segment? Who can tell me?
It is done in IP layer.
Yeah. Okay, it's not part of TCP. TCP, it means that packet has arrived at the node, and then you need only port number to be delivered, right? And when this gets encapsulated IP layer, then IP addresses will come. Then you have sequence number. Okay, okay, what is being sent, that sequence number, right? And then acknowledgement number, what has been received, okay, at the other end, right? Okay, now note sequence number is not in TCP. We don't use packet number here. It's not 1 2 3 first packet, second packet, third. That's not the way, right? We need the first byte in the stream. I mean, it is a big stream. Okay, so this data is going into first TCP packet or segment. Look at the address of the first byte. That goes into, and then second segment, the address of the first byte of here in the stream. This could be 0 to 9999, and the second one will be 1000. So this will go as a sequence number. Okay, all right. So there's a difference. Never think in terms of packet number. We are not numbering packet. We are numbering this byte number. Okay, all right. And then there are some other fields here, right? Of course, there is a checksum. Checksum does only very little amount of work, right? It just finds out something is, in general, in networking, it's not designed for true reliability. Okay, so we have few bits for checksums. So basically look at the payload and see if something is gone wrong, then one or, you can find out if something is gone wrong. This first aspect. Second is that can you correct if there's 1 or 2 bits have gone wrong, few bits have gone wrong, can you correct it? So that is the only purpose of checksum, but does very little. But in today's world, the networks are extremely reliable. Fiber, when you send data over fiber, then chances of one becoming zero is quite less in comparison to olden days when we had copper cables, etc. So now there is very good probability that packet reaches to other end. So checksum is usually sufficient. Okay, so apart from that, we have various fields like ACK field. Okay, now when this bit is set, okay, when this bit is set, then sequence number of, okay, so basically we will look at the concept, how it's going to be used. Okay, so basically when receiver sends ACK, it means that it's ACKing for certain amount of data that's received. Okay, and then we have, okay, let's ignore this also, and there are some other flags like RST, SYN, and FIN. Okay, now this RST is used for resetting, SYN is used for connection setup, and this is used for termination. Okay, so now we are going to see how these can be used. Now, of course, this diagram shows that byte stream abstraction. This sending process have bytes, and the receiving process also receives same bytes, right? So we create this kind of abstraction. Okay, and sequence number is nothing but the first byte of the segment. So first TCP segment, if this is a byte stream or a file, okay, so the sequence number that goes in first segment is this one, second one is this one, and so on, right? Okay, all right. Acknowledgement is always cumulative acknowledgement, right? So, all right. Okay, acknowledgement is sequence number of next byte expected from the other side. Okay, so now see if this is a packet, right? This acknowledgement field, when this sender is sent a frame, a packet, and receiver is acknowledging it, then this acknowledgement number field will say that what is the next byte that is expected from the sender. Okay, sequence number next byte. So this field will contain that. Okay, so and from this diagram you can see that, okay, okay, so this has been sent and ACKed. Okay, now here you can see that next byte that is expected will be this number will come here. Okay, all right. Okay, simple. So you can see this diagram that sequence number, if the packet is being sent with sequence number 42, then ACK will be for ACK number will show 43 because the next thing that's expecting will come from host, right? Okay, you would have seen this in your course, right? So I will just skip it. Okay, so and this is retransmission scenario that you would have seen. Okay, so if it's communication between A and B, and A is sending a segment with sequence number 92, it has 8 bytes of data. The B will send acknowledgement for 100. If it's a loss on the way, then there is a timer, it will start. Host A starts a timer and says that after it acknowledgement doesn't come within certain period, which is timeout period, then it will resend. So it will again resend the same packet, and the receiver will receive it again, and then it will know that This acknowledgement has not reached, will now send acknowledgement. And if acknowledgement reaches here, then he knows that transmission is successful. Okay. There can also be a scenario that there can be, this whole acknowledgement takes longer time to come because of some reason, right? There's some delay on the path. So there can be timeout, and then retransmission can happen. Retransmission of the packet, the first packet, for example, here, but the receiver will send the cumulative acknowledgement because second packet is also received, so it will send acknowledgement corresponding to the last packet that's received properly. Okay, so you can see, go through this, right? There's a pipelining concept is shown here and something is missed here, then that only can be retransmitted. Okay, and as a result of that, cumulative acknowledgement can come. And then there is a concept of flow control, right? Flow control is done because source and receivers need to manage the buffers, right? If sender is sending at very fast rate and receiver is not able to accept it, because receiver may be a server, there may be multiple processes that are running, thousands of processes, and each is demanding CPU time, and CPU, of course, CPU will empty the buffer, receive buffer. So while sender has just, your machine is sending at very fast pace, so your packets which are coming at very fast pace will be lost, right? So now sender will say, hey, man, slow down. Okay, so all that is done using sliding window protocol. So we'll not go into it, right? Okay, so basically there has to be something between send buffer and receive buffer, synchronization has to be there. Okay, now something that's important and which is which requires you to understand is concept of SYN. Okay, so basically first step in TCP connection establishment is, there has to be relationship between the two entities, right? And for that we know the source IP address, destination IP address, source port and destination port is required. But when we are sending the first packet, that we are not sending the data in it, right? That's corresponding to connection establishment. So this SYN bit is set there. You would have read the SYN bit, right? Just now we discussed, in the format. SYN bit is set, and then some sequence number is there, right? Note that the sequence number you would have studied in TCP is a kind of randomly generated first sequence number. Okay, and then is received, then this guy will also generate a sequence number Y. He'll set the SYN bit is 1 because now it's still a signaling protocol. Okay, and then send the egg bit as 1. It means the egg bit is there also in the TCP packet. It means that now it is acknowledging that this SYN has been received, and that SYN has been received wherein the packet number or sequence number was X. So it will say the next thing that I'm expecting is X plus 1. And now this will say X bit is 1 and X number is equal to Y plus 1. Okay, so it now this guy will know that everything is okay. Please go through this. Of course I am rushing it very fast. So SYN bit is required to establish connection. Now the question is that how this SYN bit is going to be processed. Okay, now until this connection establishment is over, this guy needs to keep data about this SYN bit, right? Which means that this IP address, so some state is to be kept for, right? The state here corresponding this connection will have all this data, right? That has been received, IP address, port number, source port number, okay, and then sequence number, And what else? Okay, etc., right? So this is to be stored corresponding to this request. Now, what kind of mischief you can think of? Note that this buffer for storing all this state information corresponding to received since from multiple sources is just, again, is a buffer, right? Or is a memory of fixed size. Okay, now you can do SYN attack. How can you do SYN attack? You are a machine or attacker keeps sending SYNs with different IP address. You generate different IP address and keep sending SYN, and this guy will keep storing them. And when a genuine person sends a SYN, he'll say, "Oh, I don't have space." Okay, this is the attack that we'll study in the next class. Okay, please go through this. Please go through this so you can understand the concepts in the next class, right? So this normal data transmission is, that there's a concept of piggybacking of acknowledgement. When B's server is sending data, it will it can acknowledge data sent by client. So there can be egg field here, then they'll say that sequence number, this is actual sequence number of the byte that it is sending. Okay, and then it will act what has been received from here and so on. Okay, all right. So this is a normal data transmission you would have seen, right? These are the flags. Something that's of interest to us is SYN and reset. Reset the connection, right? This is one way to end the connection. When machine A says that over, now I'm sending reset, let's terminate the connection. This is very fast way. Normal way is using FIN. Okay, now can this be misused? No, of course, with RST you will need some other information. Attacker, if knows that, then can send RST with this guy's source IP address, port number, and some other information, sequence number, etc. If it knows the sequence number, port number, IP number, it can send the reset packet, and this guy will terminate the connection. Okay, all right. So in general, we see that transport protocols are used for two things. First is reliable delivery. This is what TCP comes into picture. And second is multiplexing, demultiplexing, because something within a machine, there are number of process, so we need to. So this is used both in TCP and UDP. Okay, these are the two important work of transport layer protocol. Okay, and then we can now, these are all based on understanding. Note that in networking world is all distributed thing, right? And these are based on very simple thing that both ends are honest. Okay, if both entities are not honest, because it's a it's a distributed protocol. Okay, if both ends are not honest, then any kind of mischiefs can happen or attacks can happen. And in the next class we will see some of these attacks. All right, okay. Now think of the concept of port. Like, I mean, you would have seen here. Oh, well, I mean, okay, here. So these are a number of ports that are possible, right? And there any machine in your machine, right? Just check how many ports are active. Okay. Now, can you find out what are the ports active on different machines in the lab on a LAN? Okay, or your neighbor's machine, and you find out what are these ports are doing, and what all protocols they are running, and what version of the protocol they are running. See, for example, port 80 may be running HTTP. You can also find out what version of HTTP is running. And can you create a map of all that? All the machines in a particular organization, and how many ports each has, and what software it is running. Now that is what criminals want. Cyber attackers need this. If this information is there, then they know where the vulnerability is and then can do corresponding attacks. Okay, all right. This is good enough for today. See you on Wednesday, and please let me know when we can have extra class. I need 3 hours of extra class before 9th of May, so we can complete the course. Okay, all right, thank you.